me share the screen and then we'll start. Okay. So let's go back to the problem where we left the other day. We had a problem with us where the primal was something like, I'm writing the primal first and then, so I'll write its dual here, okay? So our primal was to maximize z equal to 3x1 plus 4x2 plus x3 subject to x1 plus 2x2 plus 3x3 less than or equal to 90, 2x1 plus x2 plus x3 less than or equal to 60, 3x1 plus x2 plus 2x3 less than or equal to 80 with x1, x2, x3 more than or equal to 0. This was the primal, right? And the dual was minimize capital Z equal to 90y1 plus 60y2 plus 80y3 subject to y1 plus 2y2 plus 3y3 more than or equal to 3, 2y1 plus y2 plus y3 more than or equal to 4, 3y1 plus y2 plus 2y3 more than or equal to 1 with y1, y2, y3 more than or equal to 0. Is this correct?
Yes, ma'am.
Okay. Now let's write the optimal tables that we have got by solving both the problems with simplex method. Okay. So let's see what is the optimal table for my primal problem first. Okay. This I'm sure everybody has solved. इधर हमने क्या लिखे थे? Basic variables, and these were our CJs, x1, x2, x3. There were 3 slack variables in the primal, right?
Yes,
Yes,
ma'am.
ma'am. Yes,
So
ma'am.
it was 3, 4, 1, 0, 0, 0. Now your optimal basic variables for primal would have been क्या थे? x2, x1,
X5, X1, X6,
x6. I'm talking of the
X6.
optimal table only. These are the 3 basic variables in the optimal table.
X5. Yes, ma'am. Yes.
No,
Yes, ma'am.
x5 नहीं है. x2, x1, x6.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Right? x5 है तो गलती करी है. Is that okay? So your CDs are 430. Now let's write the things column wise. Okay. So your B must have been 40, 10, 10.
Yes, ma'am.
Right?
Yes, ma'am.
Now x1 becomes 0, 1, 0. x2 becomes 1, 0, 0. Right?
1, 0.
Yeah. Now x3 would have been yeah, 5 by 3 minus 1 by 3, 4 by 3. Is this right?
Yes, ma'am. Yes, ma'am.
Then 2 by 3 minus 1 by 3, 1 by 3.
Yes, ma'am.
then minus 1 by 3, 2 by 3, minus 5 by 3. And then x6 is 0, 0, 1. Is this correct?
Yes, ma'am.
Yes, ma'am.
Right. And your maximum Z was 190. Okay? And your ZJs were 3, 4, ये कितना था 17 by 3, 5 by 3, 2 by 3 and 0.
Yes, ma'am.
And your ZJ minus CJs were 0, 0, 14 by 3, 5 by 3, 2 by 3 and 0. Am I correct or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Right.
Yes, ma'am.
This is your optimal table for your primal problem, right? Which amounts to saying that this is the optimal solution for the primal. The solution being read as x1 taking on the value 10, x2 taking on the value 40. But see, x3 is 0. See, our decision variables were x1, x2, x3. So we'll read the problem as x1 10, x2 40, x3 0, and of course x4, x5 0, and x6 10, and maximum z being 190. This is how we are going to read the solution, right? Now, but if we look at the optimal table of our dual, then since our dual was a minimization problem, okay, I'll have to keep shifting between the two pages. That means now let's write the optimal table for the dual also. Let's call the variables as y1, y2, y3, y4, y6. Of course, all the artificial variables have left. So I write it as xb only because we are writing the basic variables here. Okay. CDB. If you want to be very specific, you can write YBs. No issues with that. Okay. Y1, Y2, Y3. Now we'll be left with only 3 surplus variables. Y4, Y6, right? The coefficients here would have been, because it was a minimization problem, changed it to maximization. So your coefficients here would have been minus 90, minus 60, minus 80, 0, 0, 0. Am I right?
Yes, ma'am.
Push the button. And now your basic variables would have been optimal. Y6, Y1, and Y2. ठीक है ना? Now when you fill in the values here, sorry, right. Y6 is 0, Y1 is minus 90, Y2 is minus 60. Your B would have been kitna? 14 by 3, 5 by 3, 2 by 3?
Yes, ma'am.
Yes,
ठीक
ma'am.
है. Now your y1 will be 0, 1, 0, y2 will be 0, 0, 1. Now come to y3. Is it minus 4 by 3, minus 1 by 3, and 5 by 3? ठीक है ये?
Yes, ma'am.
1 by 3, 1 by 3, minus 2 by 3, minus 5 by 3, minus 2 by 3, 1 by 3, and 1, 0, 0. Am I correct or not? And since we are solving the minimization problem, so we have changed the objective to maximization. So I'm writing it as capital Z star. ओके ये कितना आया बताओ?
-190.
-190. ठीक है, अब ये ZJs कितने आए थे? -90, -60, -70 आया ये
70.
कितना? हाँ, -70, then 10, 40, 0, right? So your ZJ minus CJs are 0, 0, 10, 10, 40 and 0. ये आया था?
Yes, ma'am.
Yes,
Is that
ma'am.
okay? Right. Now see. That means for this problem, we have got maximum Z star, which is nothing but, we were to find minimum of capital Z, which is minus of maximum Z star, which is minus of -190, which turns out to be 190. सबसे पहले तो यही कंपेयर कर लो, ठीक है ना? And what is the optimal solution for your primal?
$190.
190. Okay. So that means we have got the same optimal value for the primal as well as the dual. That is not going to change. Firstly, which was an apprehension in the previous class, and I told you just do it and you will see it happens. Okay. Now, you know the dual solution, right? What is the dual solution that you have got? Y1 equal to Y5/3, Y2 equal to 2/3, and Y3 0, because Y6 has turned out to be 14/3, right? So basically your Y3 is 0, right? Your decision variable for the dual problem. Sorry. Now go back to your optimal primal table. Do you see those values somewhere? Anywhere in the table? Either in the last columns for Zj minus Cjs.
Yes, ma'am. ZJ minus
Huh?
ZJ minus CJ of the
Zj minus Cjs of the which variables?
see 10, 10.
X3, X4, X5.
Yes, ma'am.
Yes, ma'am.
Yeah, that's right. But then what happens is that I'll come to this 14/3 later on. Let's see here. How much is your Y1? From the dual, how much is your Y1?
5/3.
5/3.
5/3.
5/3, right? And 5/3 corresponds to what? The first slack variable. See, look at this way. What was your Y1? Y1 was the first dual variable, right? And a dual variable corresponds to what? The constraints in the primal, right? So that means whatever we are getting for the first dual is basically our information for the first constraint of the primal, right? In the first constraint, we had the first slack variable. What was that? X4. And you will see that Zj minus, in fact, Zj minus Cjs of the slack variables in the primal are actually the solutions of your dual variables, You can see it. 5 by 3 is what? Y1. 2 by 3 is what? Y2. And Y3 was how much? 0, because it is a non-basic variable in the dual. यही आ रहा है ना हमारे पास? You are actually getting your Y6 as 14 by 3. Right? So Y6 is your surplus variable. Where? In the third constraint, which corresponds to the third primal variable, 14 by 3. Okay, so if I'm just reading the solutions of the dual from the primal, just remember this rule, okay, that Zj minus, again, if your primal is, I'm repeating it again, if you want to write it somewhere, you can write it. If your primal problem is maximization less than or equal to types, you have solved the primal, then Zj minus Cj's of the slack variable will be the solution for your dual problem. Is this clear? Right? And your optimal value is not going to change for the primal as well as for the dual. So your primal problem was maximization type, so definitely your maximum small z is 190. Your dual was minimization type, and that is also 190. But mind you, remember, it does not mean that they mean the same. No, your objectives are entirely different. The real meaning of your objective functions is different, but it's just that mathematically the value has not changed. Okay, so if my primal is maximization less than or equal to types, then Zj minus Cj's of the slack variables in my problem will give me the solution for the dual. So I don't have to solve my dual at all. I just have to solve one problem. Okay, now just see. If you look at the solution of your primal problem, how much is x1? 10. How much is x2? 40. x3? 0. Now go back to your optimal dual table. If you go back to your optimal dual table, again, do you see those values somewhere?
Yes, ma'am. Zj minus Cj's
Zj minus Cj's of which variables?
of Y3, Y4, and Y5.
No, y4, y5,
Sorry,
y6.
Y4, Y5, and Y6. Yes.
So basically, that means if your dual is minimization more than or equal to types, I mean, it could be for primal also. So if you have minimization more than or equal to types, then Zj minus Cj's of your surplus variables will give you the solution for your dual. Or like if I treat this dual as my primal, so obviously the primal is the dual then, right? So in this case, what is happening? That my problem was minimization more than or equal to types. So Zj minus Cj's of these surplus variables will give me the solution for the slack variable, for the dual problem then. Is this okay? So the purpose is that the purpose is that we need not solve both the problems. Solving one problem is going to give me complete solution. So I don't need to solve the two problems. I can just solve one problem. What I need to do now is interpret the dual from the given problem. What exactly are we going to mean by the dual? Okay, that is more important here. So that is why duality basically has more of its economic significance, okay, rather than purely mathematical significance. Of course, it is mathematically it is significant because it is saving us
Sashi,
time of solving two problems.
Priti,
Uh,
bye.
did anyone say anything? No. Okay, no problems. It happens. So, okay, now coming back to this, where I was saying, I said, yeah, um, mathematically, this concept has an advantage that it allows us to solve only one problem and gives us the interpretation in both the types. But then the interpretations has more of its economic significance because, see, what is happening is that whether I'm talking of slack variables or I'm talking of surplus variables, I am talking of these variables in terms of constraints. And constraints are always related to resources. And resources are your, in a way, for example, when the example that I took, it was for a carpenter. So the resources for that carpenter were the inventory that he had to stock with himself. So resources always mean investments, because as a production unit, I am investing money on my raw materials, on my inputs. So resources are your investments and your objective function is your output, because it is either going to earn you revenue, it is going to measure your levels of profits and so on and so forth. So basically what a decision maker would want to know here is that if I change the levels of resources, how much is it going to affect the profit earned out of that unit? So that is what needs to be interpreted. So for that, duality becomes very, very important. And moreover, in fact, we call it as technically or mathematically, we call it as sensitivity analysis. Basically, what we are trying to measure is that if I change the resources, plus minus something, then how is it going to affect my profit, or how is it going to affect my revenue earned? Is my revenue going to be the same? Like, for example, here I say that the maximum profit that he can earn is 190 rupees. Okay. So obviously he's going to ask, if I change my resources, if I reduce my wood, or if I reduce my machine time, or if I reduce my polish units, then also till what extent can I change those resources so that my optimal profit earned still remains 190. It does not change. It does not increase or it does not decrease. So that is like providing the decision maker with a range, that if you want to fix your profit till 190, you can do that as long as you remain in these range of your utilization of resources. So that is called as sensitivity analysis. Okay. So, I mean, we are not going into details of that because it is beyond your curriculum, but you must know what sensitivity analysis is all about. Okay. And as I mentioned earlier also, since slack, surplus, they're all dealing with your constraints, and you are reading the solutions from the Zj minus Cjs of your slack variables only, or of your surplus variables only. So definitely they have more meaning to it, rather than only just giving us or only just providing us with the solution of the duals. Okay. See, how do we interpret this? See, one thing is very clear, like, okay, let's move step by step. So basically what we have learned from here is that, I'm not writing it again, but it's understood, or if you want me to write it for you, I can write the rules here. So we have learned that Zj minus Cjs of slack in the primal problem. Of course, when I say slack, it's understood that my primal problem is maximization 1 less than or equal to type. So Zj minus Cj of slack in the primal is the solution of the dual. Right. So this is my first rule. Okay. Is this clear? Second observation that I made is that Zj minus Cjs of surplus in the dual. Yeah.
मैम कौन सा वेरिएबल एग्जैक्टली कॉरेस्पॉन्ड करेगा दूसरे के, वो कैसे समझेंगे?
कौन सा क्या किसके
मतलब
कॉरेस्पॉन्ड
कि
करेगा?
कौन सा एग्जैक्टली एग्जैक्टली कौन सा स्लैक वेरिएबल किसके साथ होगा? जैसे यहाँ पे 14/3 y6 के साथ है,
14/3
तो
does not
x3
correspond. 14/3 does not correspond to any slack variable.
no मैम, इन डुअल
हाँ
y6 इज सरप्लस वेरिएबल और वो
हाँ
14/3 है, लेकिन y6 कौन सा zj माइनस cj ऑफ प्राइमल
y
कॉरेस्पॉन्ड करेगा?
y6
जैसे यहाँ पे
y6 सरप्लस वेरिएबल किस कांस्टेंट की वजह से आया था? प्राइमल के कौन से कांस्टेंट ने y6 was a surplus variable added in which constraint?
थर्ड कांस्टेंट
Third constraint of the dual corresponds to which variable of the primal?
कैन यू रिपीट द क्वेश्चन?
I said third constraint of the dual corresponds to which variable of the primal?
फर्स्ट वेरिएबल.
No. Every constraint of a primal gives a variable of the dual.
यस मैम.
The first constraint of the primal will give first variable of the dual.
यस मैम.
So y6 was in the third constraint of the dual.
यस मैम.
Third constraint of the dual corresponds to which variable of the primal?
सिक्स्थ.
Six तो variables ही नहीं थे बेटा primal में.
आई एम गेटिंग कंफ्यूज्ड देन.
Just remember one thing. Every constraint in the primal is a dual in the variable. Is a variable in the dual.
यस मैम.
Every variable in the primal is a constraint in the dual. When you are
यस
writing
मैम.
that, when you are writing the dual, तो सामने देखते हो ना, जो फर्स्ट कांस्टेंट है प्राइमल का,
हाँ हाँ.
वो सारे को वो सब कहाँ डिफाइन करता है? y1 का कोएफिशिएंट बनता है ना
हाँ
फर्स्ट,
हाँ हाँ.
right?
हाँ.
So y6 was in the third constraint of the dual and third constraint corresponds to x3.
हाँ मैम.
So इसका मतलब y6 जो भी इंफॉर्मेशन देगा वो x3 की देगा ना?
यस मैम.
Is this clear now?
यस मैम.
Right? So abhi to just understand this, that zj minus cj of slack in the primal is the solution of the dual.
यस मैम.
Right? So अब जो first slack है हमारे पास primal में, that is x4.
यस मैम.
So obviously x4 corresponds to y1 because x4 corresponds to the first slack variable. First slack
Yes.
variable is added in the first constraint of the primal,
यस मैम.
and first constraint of the primal is giving you the first dual variable.
First constant of primal is giving the. Yes मैम.
Right? So first slack corresponds to y1.
Yes मैम.
Is that okay now?
Yes मैम. Yes मैम.
Right? Similarly, zj minus
Second,
cj of the
second slack will be corresponding to second constant
Dual
in the
variable.
Yes, yes ma'am.
Is this clear now?
Yes ma'am.
Right. Similarly, zj minus cj's of surplus in the dual will be the solution of the primal. This is how we are going to interpret. Right. Now, the obvious question that should come up to it from you is कि ये तो सब तब हुआ, well, all is well. That means my primal also is giving me a proper solution, and so I am interpreting the solution of the dual from that, right? What if my primal is unbounded? Or what if my primal is infeasible? Then how do we go about it? Okay. So for that, just remember one thing, that if if the primal is unbounded, this we can end up. That means your dual is infeasible. So you don't have to solve the dual then. You just solve your primal and you conclude that your primal is unbounded. Okay. Then you can clearly mention that the corresponding dual is going to be infeasible. So you're not going to get a solution for that. Similarly, if your primal is infeasible, that means your dual is unbounded. Is this okay? So, and of course, infinitely many solutions, then both are going to give you the solution, because in that case, the only problem is that your more than one basic variables will be zero for the dual. We'll
I
come
have
to
a
that
doubt.
problem later on. Okay. But then let's see this rule. These are the rules to be followed for interpreting the solutions. Is this rule clear to all of you?
मैम
Yeah.
एक डाउट है कि ये जो हमने प्राइमल और डुअल वाला लिया था, उसमें हम दोनों का इन दोनों का ऑब्जेक्टिव फंक्शन जो था वो दोनों डिफरेंट था। एक में
हाँ।
हम उस मतलब प्रॉफिट को मैक्सिमाइज कर रहे थे और दूसरे में कॉस्ट को मिनिमाइज कर रहे थे। लेकिन तो मैम दोनों का तो वैल्यू अलग आना चाहिए था ना, क्योंकि उसमें तो हमारे जो वेरिएबल्स थे और वो भी डिफरेंट थे।
It's like, नहीं तो क्या हुआ? That's what I'm saying. That's what I'm saying, because there was a restriction. The restriction was that the decision maker wanted to earn at least a fixed amount of revenue. And what was that fixed amount of revenue? The profit that he was actually getting from selling each of one table, one chair, and one bookshelf. So since the upper limit was fixed on that, see, it's like, imagine like you have two hyperplanes, it's like one sort of a convex set, the other sort of a concave kind of a shape. Both are overlapping but meeting at exactly one point, which is the minima of the upper part and the maxima of the lower part. So that point is not going to change. If you change their shapes, right? So it's like, I mean, it's a very rough thing that I'm trying to explain, but it's like something like you have one thing like this, the other like this, and you are meeting at this point. If you change the shapes, that means you are changing the coefficients. So obviously your value will change. So you are changing your constraints, you are changing your restrictions, you are changing the objectives. See, mind you, our guiding numbers were 3, 4, 1, 90, 60, 80. Right? In one function, these were the coefficients in the objectives. In the other, these were the coefficients in the objectives. So when when 3, 4, 1 were the objectives, these were the constraints on the right hand side. These were the numbers on the right hand sides of the constraints. So it's like they were defining a boundary. So each one of them, we have not changed the boundary values. That is why we are getting only one number for that. You change the boundary values, you will get different values. So your values will change only when you change your boundary conditions. Earlier, we were trying to maximize this, keeping these as my restrictions. Then we were trying to minimize these, keeping these as restrictions. So it's like they are like two binding planes which were trying to put the things under control. So since we have not changed that, that means the shape of the corresponding hyperplanes that we are going to get for the constraints, that is not going to change. And that is why both of them will intersect. They touch each other at exactly one point, which will serve as the minima for one and maxima for the other. So that is why you are getting the same value. And you can say, yes, geometrically, yes, we have understood it like this, but simplex algorithm or the process of writing the duals for the given problem, they are so sensitive that they are able to realize that algebraically we have devised it in such a manner that we are going to get that. And if you want, I mean, I've just given you a logic of this. In the next class, we are going to theoretically prove this, that why they are equal. Is this okay?
Yes, ma'am.
Okay, ma'am.
So, I mean, there is a theorem. That's why I said the other day also that we have a result which actually proves this. Fine. Now, I wanted to go in for the interpretations of these slack variables. So, but it's going to take time, and I think we are done with the class. Hardly a few minutes left. So I won't start it now. I'll do that in my next class, because what we are going to do is interpret. Like if I just go back to the solution of the primal, you see that what we are getting here is that, yeah, we have x1 in the basis, we have x2 in the basis. Okay, so because we have one slack variable in the basis at this value, so this has its own importance, and because of this we have y30. Okay, so I mean, these are going to give us some more information about the resources that we are going to learn. And because of, I mean, these are called as the marginal prices or shadow prices that we are going to talk of, because they're going to tell us what resource is lacking what. Okay, so then I'll start that, do that in my next class, and plus the theoretical results that we have to do. Is that okay? So I think I'll finish off this class now here. And if you have